July 1941. A Bletchley Park code breaker, Alan Turing, and his team decrypted Enigma. I love to think that first ever computer, first ever software developer, first ever software has been designed to save human lives. September 9th, 1947, 6 years later. Computer operators in Harvard, searching for a cause of a problem, found a moth slammed in one of the relays of their computer. They removed the moth, they made a note in the journal, they taped the moth into the journal, and they have written, first actual cause of a bug being found. So, first ever bug. One of the members of the Harvard team, Grace Hopper, a pioneer of computer engineering, she is attributed to calling removal of the moth as a debugging the system. September 20th, 2007, 60 years later, Barbara Schwartz, a resident of Yukon, Oklahoma, has been killed as a passenger of a 2005 Toyota Camry, which inadequately accelerated due to single byte flip in the computer software. Ladies and gentlemen, this is the day we software developers started killing people. My name is Tim Bezhashvyly. I'm a CTO of Hidden Hint, a software company in Switzerland. We are very proud that we emphasize on a very high standard of code quality. And we are actually taking new customers, and our rates are very competitive, especially comparing to the United States. But don't take it from me. Here is what our customers and people who are working with us are telling about us. But today we are going to talk about the code smells. We are all familiar to the code smells. Those are the red flags we see in our code, which indicates us about the problem, which indicates us about that something has to be changed. We may ignore them. The smell will become stinking and consequently a notorious big ball of mud. But if we all know them, why we are talking about them today, let me tell you a very short story. In 2015, I was teaching design patterns. I was very passionate about design patterns, you know, the book of design patterns by Ganger 4. And then I participated in a PHP user group in Berlin. And there was Anthony Ferrara, who was making a presentation called Beyond Design Patterns, where he completely deconstructed design patterns. He questioned the fact how useful they are, especially in the object-oriented programming. And me, as the proponent of the design patterns, of course, I was furious. I mean, like, I thought, like, what a teenager approach against the eternal values. And I went home, but a seed of doubt has been planted. And years later, it grew into a fact that I am so agree with Anthony's presentation back then that I named my today's presentation Beyond Code Smells as a tribute to his presentation 10 years ago. And yeah, you maybe guessed it right. I will try to debunk the classical design code smells today. So what is wrong with them? The thing with the code smells, the classical code smells, is that they normally indicate that the problem that is already there, the problem that we have to fix. I was thinking that we need something to understand the problem upfront before it has been created. So I will try to go through all those, not all those today, but so what actually wrong with the loan method? The thing is that we understand that the method is to loan when it's already to loan. The loan class, the large class, is already too large when we see that it is large. We are not like keeping the number of lines in the hand and then coding and then at some point of time just splitting the method into two. Same goes for alternative classes with different interfaces or inappropriate intimacy, lazy class. The class is already there when we see that it's problematic. The duplicated code is duplicated when we already see two versions of the code. We are not explicitly copying and pasting it to create a duplication. Same goes to oddball solution, because in effect, oddball solution is a sophisticated version of a code duplication. Yeah, the shotgun surgery. We already find it out when the surgery is underway. But I'm not going to, I think some of the code smells are actually allowing to eliminate the problems at the early stages. For instance, the comments. Comments is one of my favorite code smells. But I find it the hardest to convince the developers to follow. Somehow developers are very, very resilient writing code comments, even though we are not in the 90s anymore, where the code would not be accepted unless it has tons of documentation and lots of code comments. Nowadays, we all agree that code must be readable and self-documenting. However, this is not the only problem of the code comments. Code comments start a line with time when the code changes and we forget to change code comments. Another problem of the code comments that sometimes we are writing code comments for no reason at all, just for the factor that they are there. Especially, I'm wondering why people are so insistent on having the doc blocks, even though all the types of the methods are clear from the signature and the return type. The doc block is still put in place, when in fact the idea of the doc block is to make your IDE smarter, but IDE can already read everything from the signature. So the doc block in this case just creates a visual noise which makes code less readable. So today, at the rest of this talk, I'm going to talk about the small things which can be used as the code comments in the early stages of the software development in order to keep your code from the code smells up front. The first one would be the single indentation. The idea is that in order to keep the method short, the indentation must be always maximum one depth. here you can see the second depth, and this must be refactored. How do we refactor it? We refactor it just extracting the method. Next, else. Else must never be used. Else is the clear indication of the single responsibility principle violation. Instead of else, we use an early return. So the code like this will be converted into something like this. It also will improve the testability of your code, because it will make your code coverage better. Now, the setter. Same as else, the setter must never be used. The setter is an indicator that you either have flow or design problems in your code. Why? Because the setter allows that your object is at one point in a not ready state. It means you need to set something in order for object to be in ready state. All the partials of the object must be injected via either constructor or the productive method. During the last 15 years of my professional career, I never had to use a setter, which means absolutely you can avoid using it. And if we are talking about constructor, the next thing would be that constructor must not have any productive code, because the role of the constructor is to initialize an object into the same state so it's ready to work. And if it is not possible to initialize an object, the exception must be thrown to prevent existence of an object in a not ready state. And by real work, I mean that the real work is normally heavy, which will make the creation of an object slower, which is undesired and unexpected. And under no circumstances, constructor must have input-output operations, which means connect to the database, talk to third-party services, and especially file system operations. Because, first of all, it will make the creation even slower, and then it will require that whatever the constructor is talking to must be present at the time of creation. But what about the database connection, you will ask me? The database connection must be put into a wrapper object, and it will be lazily loading the connection. The object will be injected into your class. So the connection will be created on demand if not yet created. Let's go back to primitives, the magic primitives. What is the problem of the primitives? The main problem of the primitives is that they are poorly traceable and poorly maintainable. Means if you need to change a primitive in your code and you have multiple instances, it's very easy to miss one of them while changing another. And the other way around, if your IDE is replacing a string or any other primitive, it can replace identical primitive even though they are not logically connected to each other. Then primitives are not self-documented and they are very error-prone. And yes, there are also magic booleans. So I'm pretty sure you had occasion in your work when you have to flip some functionality 180 degrees, and then you have to go through your code and change multiple booleans, and you definitely miss one of them, and this one of them would be the single byte flip, which will kill people. Hashtag just saying. At some point, your primitive will evolve into the value object. A value object, the indicator that the primitive has matured enough to be converted into the value objects are validation, if you need to validate the string or check that the number is negative or positive, whatever. Normalization, if you need to trim a string or sort an array. Array is also a primitive, of course. Operations, if you need to do some mathematical operations or maybe string operations, this is another indicator that primitive is a good candidate for a value object, and the clumps, of course. And sometimes value objects can be combined from another value objects. The good example here would be RGB color or coordinates, where each color or coordinate is a value object itself. And important point, ID is always a value object. New. Creation of an object must never be done on demand. Either injected via constructor and/or factory, or the value object can be created via static constructor. And the dependency injection container is an anti-pattern and must be absolutely avoided. Next one, this is the big one. Every class, absolutely every class must be declared as final. Yes, this means no inheritance. There are lots of articles on the internet way back 10, 15 years discussing why inheritance is bad. And in fact, lots of the classical code smells will cease existence if no inheritance is used. And also, one of my mentors and the person who influenced this very presentation, Stefan Pripsch, he has the whole course on why inheritance must not be used and composition must be used instead. And I believe this course is in German. Otherwise, I'm pretty sure he will also release it in English. If you are not convinced yet that inheritance is a bad thing, you may want to take a look into this. Next one. After I have landed some heavy bombs, I would like to go through a couple of very quick code smells which can be used, like helpers. Helpers are normally the classes where we put everything we don't know where to put. So this is definitely single responsibility principle violation and indicator that you need to rethink your design. Silent death. Here is an example of a silent death. If we are doing something, we can expect that the caller is notified if we fail and not die silently. Especially, the good example is an input-output operations. Next, CQRS. If your class is reading and writing, pulling and pushing, asking and doing, this is a good indicator that you are violating the command query responsibility segregation principle. Flags, default arguments, also nullable arguments. This is, of course, the clear indicator of single responsibility violation also, and you most probably need to create several methods which will then share one internal. And now I'm getting to my final three code smells, which will be a little bit provocative. I do not expect you to adhere to them right away. Most of you will think that I'm just talking nonsense. What I'm hoping is that you will leave this room with the seed of a doubt, the same seed I left a room on the Invalidenstraße in Berlin 10 years ago after listening to Anthony Ferrara. So we have spoken about the setter being a code smell. You guessed it right. Getter is also the code smell. Not that kind of the code smell that you have to eliminate right away, but the rationale behind of it is that the model must speak use cases, behavior versus data. I will give you an example. This is a problem I faced several months ago, real life code, very simplified. I have a data view model of a product. It exposes stock keeping unit of a product, and then I have a button, the code which generates the button for adding for the wish list. And this code is used in the SKU. So following my logic, the refactoring must be like this, where you don't expose the SKU, but do the clear behavioral method name, and then it's used inside of the button. It has no idea that the product has the SKU, but it must not. The next one is another unorthodox smell, is a variable. Variable is a code smell also. Another short story is, I was reading a book several years ago. Unfortunately, I don't recall the name. It was the book from the 80s about principles of programming, and the authors were like shooting the principles of the programming one by one, very good. What I was shocked is that already after the middle of the book, they introduced a notion of a variable. What I was even more shocked about, that the manner in which they introduced it, it was like excusing. Unfortunately, we now must use a variable. And after something changed in me, and I was not able to think about the variable the same way after reading this book. Because what is a variable in essence? It's a temporary storage for some data which we may use later. Already sounds very dirty. So I'm not asking you to eliminate all the variables all at once, but every time you want to add a variable, think about that this is a good candidate for being either extracted or inlined. You will be amazed how more concise and readable your code will be. The last one. This is following the same vein as my previous two code smells. This is a null. Null to me feels like even a greater excuse. It's like even throwing an exception will make more sense than returning a null. Null sounds like, sorry, we were not able to return any suitable value for you, and the void is not an option, so here is your null. So I have been talking to my colleague recently, and he's from a Java world, and he is, I asked him about the points of this presentation, trying to test this against him, and he was not even sure why it isn't that so obvious that the null is an anti-pattern, because in Java world null, which is called nil, is very discouraged. He even thought I was talking about the null pointer. And then I recall that many programming languages do not have null at all. I think Udi de Haan completely nailed it with this quote. Null indicates that semantics of two worlds are not aligned with each other. And with this brilliant quote of this one of the brightest minds of modern computer scientists, I would like to finish my presentation. Thanks.
Thank you, Tim.